Okay, welcome to Let's Get to the Marks. This is a question pack on buffers. Let's get straight into it. Okay, so we've got this question here. It says a buffer solution with a pH of 4.50 is made by dissolving X grams of sodium propanoate, C2H5COONA, in a solution of propanoic acid. The final volume of the buffer solution is 500 centimeter cubed, and the final concentration of the propanoic acid is 0.250 mole per decimeter cubed. Calculate X in grams. So X is our unknown integer for the amount of grams of sodium propanoate that's been added to this acid. We've also been given the Ka, which is 1.35 times 10 to the minus 5 mole per decimeter, and that's of the propanoic acid. It's a big fat 6 marker. So we're going to look at how to work through something like this. There's a little bit of a skill for these that can be learnt. And even if you aren't the best at interpreting these questions, you can break things down. So let's go through and break it down little by little. So first of all, we've been given a pH of 4.50. That's the pH of the buffer solution. You've also been given this, which we don't know what that is. That is the unknown X, but that is mass. So immediately I see mass. As a chemist, your exam technique should tell you immediately, look at that triangle, looks like a wizard's hat. You should immediately do mass over mR times moles, and you're probably going to need to do that. The moment in chemistry you see mass in grams, you're more often than not, 99% of the time, you're going to need to use this equation. So learn it off by heart. Now, this is sodium propanoate. What is sodium propanoate? Well, it's a salt, okay? It's a salt made between propanoic acid and like sodium hydroxide and a base or something like that. So we've got our salt here, and we've been given the formula of it. And this further confirms, because from this molecular formula, C2H5COONA, I can work out the MR, which further confirms that I'm probably going to need this mass over MR and moles, right? Although we want to find the mass. The final volume of the buffer solution. Okay, so once it's added to this acid, the final volume is 500 centimeter cubed. You've got to ask yourself, when you see centimeter cubed, what is that? And of course, that is a volume. And it even tells us the word volume. So V, and we're starting to see, oh, look, V, and the final concentration, remember concentration C, is 0.250, and that's of the acid too. So the moment you see V and C, you should work out in your head, hey, I know I've got to use this. Now, even if you fluff your lines here and you're completely baffled because you haven't worked through lots of buffers packs and got yourself used to this, you should be able to now pick up, once you can identify those key things, you should be able to pick up marks for working out several of these equations. Okay, and the final bit of info, we've been told the Ka for propanoic acid. Now, the fact that this is a buffer calculation, there is an equation you all need to learn off by heart for buffers. And it's you can learn how to rearrange it from the weak acid equation, but there's no point. Just memorize this. Hydrogen ion concentration, shown by the square brackets, that's what the square brackets mean, is equal to the Ka over the acid with the times, God, I can't speak properly, multiplied by the acid concentration over the concentration of the salt. Really, I'm trying to find the mass of salt. That's what we're missing. We're missing this, the mass of the salt. So we know that the mass of the salt, which is what we want to do, is MR times moles of salt. So I can work out the MR of the salt. If I do C2, that's 2 times 24 plus 5 for the 5 H's is 29. We've got plus another 12 plus 32 for the oxygens plus 23. I'm going to get 90. Is that 96? I think that's 96. What is that? Yeah, 96. So what I need to do now is find the moles, and then I can work out the mass of the salt and get my beautiful 6 marks. So let's work out how to get the moles. We're going to have to rearrange this equation. We're going to have to rearrange this equation to make the salt the subject, right? So I can find the concentration of the salt. So first of all, we're going to work out the pH here. We've been given the pH 4.50. I can turn that into the hydrogen ion concentration. So what you need to do is on your calculator, press shift, then log, and then put in minus 4.50. and press your equals button, and you're going to get 3.16 times 10 to the minus 5. Now that's the hydrogen ion concentration. So we've just worked out H plus, and you're going to get your first mark on the board. Whoopee flipping do. Okay. Next thing, we need the acid concentration. We can see that we've got the Ka. So we know that 3.16 times 10 to the minus 5 is equal to the Ka, which is 1.35 times 10 to the minus 5. And then that is multiplied by our acid concentration. So we need to work out the acid concentration. We don't really need to work it out. We've been given it. It's 0.250. So we've nicely been given that. And then we're left with the salt concentration, which is our unknown. We have all the data here. We need to rearrange to find the concentration of the salt. So how are we going to do that? Well, we can get the salt over to... We can move the salt over to the left by timesing both sides by the salt, and then we can divide both sides by 3.16 times 10 to the minus 5. So what we're going to end up with when we work this out is 1.35 times 10 to the minus 5. We're going to times that by 0.250. Now we're going to divide this by 3.16 times 10 to the minus 5, and that is going to equal 0.1067, and that is our mole per dm of salt. Now the salt is obviously sodium propanoate. I'm just calling it salt here for ease. So we've now worked out our moles of salt. So actually just using this equation will pick us up a mark. Obviously working out the MR there has picked us up a mark. Now we've got the concentration of the salt. I want to use that to find the moles of the salt so I can stick it over here and work out the mass. Times this by the volume. Well, it says the final volume of the buffer solution, the whole thing, is 500 centimeters. So we want to do conc times volume. Of course, we want to do this. So we want to do 0.1067. Now we're going to times that by the 500 centimeters, but first we must convert into decimeters. So we're going to times by 0.500 decimeters, and that is going to give us our moles of salt. And if we do that, we're going to get 0.0 with a little bit of rounding, 0.054, and that is our moles of salt. Now I know my moles of salt. I can come up here and I can times my moles of salt by the MR of the salt. And that's, we already set this equation up over here. By the way, you'd have scored another mark over here for working out the moles of the salt. And then we're going to do this calculation here, 96 times 0.054, and we're going to get 5.18 grams. So we're going to have 5.184 grams or something like that. So your final answer is going to be 5.18 grams. And that is how much was dissolved in there. 5.18 grams, and that's the final answer. So you pick a mark up there. Hopefully I got to put all the 6 marks down. You get 1 for the working out here, 1 for that, 1 for rearranging the equation properly down here as well, rearranging the equation. So that'll be your 6 marks. Okay, we've got another buffer question here. It says 9, excusez-moi. It says a student prepared a buffer solution by adding 0.0136 moles of salt, Kx, to 100 centimeters of 0.5 mole per decimeter solution of weak acid, HX, and mixing thoroughly. The student then added 3 times 10 to the minus 4 moles of potassium hydroxide to the buffer solution. Calculate the pH of the buffer solution after adding the potassium hydroxide. For the weak acid HX at 25, the value of the acid dissociation constant Ka is 1.41 times 10 to the minus 5. Give your answer to 2DP and it's worth 6 marks again. So again, try your skills, pause the video, have a go. Okay, I'm going to go through it. Now, the first thing to do is, it's a buffer. I've seen the word buffer, so I'm pretty aware that it's going to be buffers. I've now been given my moles, my N of salt Kx. And it looks like I've been given a volume again, and I've been given a concentration. So immediately, I know we are definitely going to have N over CV. And this is of a weak acid. So I've been given the tools to work out the moles of a weak acid, and I have the moles of the salt. The student then added 3 times 10 to the minus 4 moles of sodium hydroxide to the buffer solution. Calculate the pH of the buffer solution. So I've also got moles again, but this time it's of KOH, which is a base. And we've been given the Ka. So I know straight out the bag that I'm going to need to do H plus is equal to Ka times acid over salt, like that. So H plus is equal to the Ka times the acid over the salt. So we need to do the same kind of thing again. And it says here, calculate the pH. And of course, pH we get from the hydrogen ion concentration. Remember, if I do the minus log of the hydrogen ion concentration, it's going to give me the pH. That is going to how we're going to get the pH. So I don't need to rearrange this equation. I just need to put in Ka and have the acid over the salt. Now you'll probably get 3 out of 6 if you just work out the concentration of the acid and the moles of the acid and the moles of the salt, and there be done with it. Whack it in there with the Ka and then inverse log the pH. You get 3 out of 6, but you'll have forgotten to take account of the potassium hydroxide situation. So let's work through what we're going to do here. So first steps up, I'm going to work out my concentration of acid. So for the acid concentration, I'm going to do 100 centimeters, which is the volume, times the concentration. Don't forget to change the centimeters into decimeters. So I'm going to do 0.1 times 0.500. And this is going to give me 0.05, and that is my moles, which I use at N for, of HX, my weak acid. So I have 0.05 moles of that. Now I do know that I also have 0.0136 moles of my salts. Okay, so that's great. I almost feel like, yeah, I can get ready, but we've got a little problem. We've added some potassium hydroxide into the situation. So what I need to do with the potassium hydroxide is think about the base. What does it react with? How does the situation work out? Well, essentially, when you add a base to this buffer solution with this weak acid, that base is going to use up some of the acid and increase the amount of the salt. We're adding this base, and just to show you what's going to go on, essentially, you're taking potassium hydroxide and you're adding it to this acid, and it's reacting in a one-to-one situation. And we're going to be left with Kx plus H2O, and there's no extra coefficients to add in. It's a one-to-one. So essentially, we're going to increase the amount of salt. We're going to go 0.0136 plus 3.00 times 10 to the minus 4. So that's actually going to increase our amount of salt, and our salt is going to go up to 0.0139, and so the salt has actually increased. But what's happened to the acid? Well, obviously our acid concentration has gone down, so I need to do 0.05, and I need to minus 3 times 10 to the minus 4, and that's going to give me 0.0497. And so all I need to do to work out the hydrogen ion concentration is smash these into the equation. So I really need to do 0.0497. Now you might say, sir, but that's moles, right? This equation has square brackets, it's concentration, but the volume is equal for both of these. Now, if it wasn't, then we'd be in a different situation. But the final volume of the buffer solution is 5 where is this? Where's the volume? Well, the volume, sorry, is 100 centimeter cubed. So the volume is equal, whatever it is for both of them. So the ratio is going to stay the same. So we can just do that. I want to times it by the Ka. So I want to go 1.41 times 10 to the minus 5. and I'm going to multiply that by this, by my new salt and acid concentration. And we are going to whack that in the old calculator, bada bing, bada bang, bada bong, and we're going to get a hydrogen ion concentration of 5.04 times 10 to the minus 5. Now that I have the hydrogen ion concentration, you just got to come down here and do minus log that, and you're going to get the pH. So minus log, whack in the 5.04 times 10 to the minus 5, and let's see what we get. And we get a pH of 4.297. Remember, we need to go to 2 dp for that sixth mark here. So we're going to round that up to 4.30. That is our final answer. Okay, I've got my kids going absolutely mental next door, which has made this video very, very difficult to get through. But I hope this helps. Make sure you subscribe, like, and share, and all that business. It helps grow the channel, and it makes me put the effort in to make more videos. I haven't been making a lot of videos lately, but I will get back on it. The more and more people watch the channel, the more I'm like, oh, you know what? Let me get back into this. All right, let's go. A buffer solution, we've got a third question here. I'm going through with buffers. So a buffer solution contains 0.025 moles of sodium ethanoate dissolved in 500 centimeter cubed of 0.0700 mole per decimeter ethanoic acid at 25. A sample of 5 centimeter 2 mole per decimeter HCl is added to the buffer solution. Calculate the pH formed. And we got the Ka. So straight away, look, it's telling me it's a buffer. I know it's 5, not 6 marks, but still, I know I'm going to need the old buffer calculation. So by now, you need to know this off by heart, times the acid, or HA, whatever you want to write down, over the salt concentration. Now they've asked me to calculate the pH. So once again, I need to work out H plus. That's some dodgy H, obviously. What have I been given? I've got 0.025 moles of sodium ethanoate. So that's my salt, and you've been given moles. Dissolved in 500 centimeters. I've been given volume, and I've been given concentration there. And we've also been given volume and concentration of hydrochloric acid. So you definitely know you're using this, but we've got no mass in grams on this one. So probably leave the mass and grams alone. We won't need it. You'll literally just need N over CV. And you'll have to take into account that the moles of the acids and the salt are going to change. Okay, so we've got 0.2, so my salt is 0.025 moles. And we've also got our acid. We can work out the acid. We haven't been given the acid moles nicely. So they've told us we've got 500 and 0.07. So that's the volume and the conc. So remember to convert cm cubed into dm. So you just divide by 1,000. So you're going to do 0.5 times 0.07. And that is going to give us our moles of acid. And that equals 0.035. And that is moles of acid. So we now have our moles of acid, our moles of salt. Beautiful. Next step, what we have going on here, we've added some hydrochloric acid. So we're going to need to know moles of HCl added. Now, if you forgot to take account of the fact that the original salt moles and acid moles that I just worked out, the 0.025 of salt and the 0.035 of acid, they are going to change because we've added an acid to our buffer. So it's going to change. And this time we're not adding an alkali or a base, we're adding an acid. So the moles of acid are going to increase and the moles of salt are going to decrease. Now, it'd be kind of important to work out the ratio because it might not be a 1-to-1 ratio. But first of all, let's work out the moles of HCl added. So I want to do 2 times, oh my gosh, divide 5 by 1,000. So we're going to go 5 over 1,000 times that by 2, because that's the volume times the conc, and that's going to give us our moles of HCl, which is 0.01 moles, and that is HCl. So all you need to do here is the acid moles are going to go up because you've added acid, and the moles of the salt are actually going to decrease. So what is it going to increase by? Well, I need to add 0. I need to do this. 0.035, which is my acid, plus 0.01. So I'm going to get, running out of space. I'm going to get in my Ka equation here, if I just delete this out, my acid is now going to be 0.045. And let's delete this out here for the salt and work out what our salt's going to be. Well, to work out the salt, I want to do 0.025 and I want to minus 0.01. Okay, now I could write the equation out to show you how, but run out of room. Okay, so why does the acid concentration go up, or the moles of acid, and the salt go down? Well, HCl is a strong acid, fully dissociates, so essentially you get loads of hydrogen ions. Remember, buffers contain a weak acid, and the salt of the weak acid, sodium ethanoate in this case. Those hydrogen ions right at the bottom here, you can see reacting with the ethanoate ions, so decreasing the amount of salt, but they're increasing the amount of ethanoic acid present. So our ethanoic acid concentration is going up, and our ethanoate ions are going down, so our salt is going down, and that's why the salt and the acid concentrations change when you add an acid to a buffer. So what's happened here is essentially I've added 0.01, which is the moles of hydrochloric acid, to the moles of acid of ethanoic acid. So I end up with 0.035 plus 0.01, and I get 0.045. That's my acid. Then I need to take away the moles of acid added, the 0.01, from the salt, which is 0.025, and that leaves me with 0.015 moles of salt. Again, we've got the same volume. I think it was 0.5, but you could add the 5 centimeters, so it's like 505 centimeters. The volume's the same for both because they're in the same solution. So therefore, I don't need to convert these back into concentration. I can just leave them as moles, 0.05 over 0.015, and I just need to times that by the Ka. Now, my Ka, of course, is 1.76. It's given to us in the question, times 10 to the minus 5. I need to multiply that, and that's going to give me my hydrogen ion concentration. And our hydrogen ion concentration is going to turn out to be 5.28 times 10 to the minus 5. So what I want to do now is, again, you're going to have picked up 4 marks already. We're going to have got marks for working out the moles of hydrochloric acid, marks for working out the moles of acid. You were given the moles of salt, so no marks for that. Marks for working out the new moles over here. Marks for working out the hydrogen ion concentration. And then our final mark is going to be for converting that hydrogen ion concentration into pH. So you just want to minus log. Whoops. Don't know how I've written that out. That looks well dodge. So just minus log that, and that equals, I've got 4.27, 4.27736. So I'm going to round that up to 4.28. And that is the pH. 4.28 is what you should have got. All right, people, help a poor teacher out. Sharing's caring and all that. Hit the like, punch the bell, subscribe. Let's get to the marks. See you on the next video.
You're still here? It's over.